Okay, guys, so this lesson, we're going to talk about what happens if a charged object and comes in contact with a neutral object. Okay, so before we were saying this, we say if we say positive charge and positive charge, they repel each other. Negative charge, they repel each other. But a positive and negative, they will attract each other, right? Okay, so let's say, well, what if it's a neutral object? So let's have a quick look. So first, we're gonna talk about electrical transfer, okay? So say this. In your notes, we had something that is positive charge. Say this thing is positive charge. And then let's say this object is a neutral object. Neutral object positive, let's say 3 positive and 3 negative. So this is neutral and this is a positive charge, right? If they touch each other, if they're going to touch each other, once they touch each other, you can see because these are positive charge, they will be able to attract these electrons to move over here. Okay, I'll draw an extra one. And they're going to attract the electron and move over here. So now, let's say not all electrons are going to move. Let's say 2 electrons is going to move to this positive charge now. So now this object will all of a sudden have 2 negative charge over here. 1, 2, 3, 4, 5, 6, 7, 8. So you can see this will still be positive charge. So positive charge. This was neutral. Now this will still be positive charge. And then let's look at this object over here touching it. So now 1, 2, 3, 4. And then there will still be 2 negative charge. And now this object has become positive as well. Okay, so this is the reason why if something is positive, it touches a neutral. And then this becomes positive as well, and this is positive as well. Okay, so sharing positive around, so positive touching both become positive. Okay, yeah, okay, sweet. So then the next one, let's say if we have some negative over here. Oh, by the way, proton do not move because proton is stuck in the middle. Okay, that's why the positive one always stay the same. Electron negative is the only one that can move. Okay, all right. Say this one. This one, I got some extra negative over here. 1, 2, 3, 4, 5, 6, 7. Let's draw 8. Okay, 8 negative here. And then again, now I have an object that is neutral. Plus, negative, 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 negative. Okay, so what happens if they touch each other? Well, if they touch each other, then these negative, they want to repel each other, right? They want to get away from each other because negative repel. So now these negative is going to be moved onto this one. Say another one moved onto here. So after they've touched each other, okay, let's say, well, 1, 2, 3, 4, 5, 6. 2 of them move to this one. So now this one has become 1, 2, 3, 4. That was the original proton. The original electron is still there, but now it has gained another 2 electron. Another 2 electron. So now if we look at this one, and that is still negative. And look at this one has become negative as well. Okay, so that's negative. And this is neutral. Okay, so this is called a static electricity and transfer. So it has transferred, positive become neutral, neutral become positive. Well, if one is positive and negative, they touch each other, then they're going to try to neutralize each other as well. Okay, all right, so this is what happens in this situation. Okay, so now we're going to take this away, and we're going to look at another situation when they're not touching each other. This is when they're touching each other, and then let's look at a situation where they're not touching each other. Okay. Okay, say here, if you have an object, say this charged, or this one we say charged object, attract neutral object. Okay, let's have a look. Why does a charged object attract a neutral object? Okay, let's say this. Let's first talk about positive. If this one is positive, over here there were positive and negative, right? So originally it was all neutral. But if you have positive over here, these electrons is going to move to the closer side over here. Okay? So electrons move to the closer, move side to the positive rod. Okay? And why does that happen? Because opposite charge attract. Okay? Because they attract negative electron move here. Okay? And this positive charge cannot move. So sometimes people will say, oh, they got repelled to this side. They did not repel to that side. Rather, they were originally there. And once these negative can move to this side, and then this side just become positive. Okay, so leaving the far side, say positive. Okay, so now this side. So now this is what we call an electrical induction. Okay, so this is called electrical induction. Okay, so what is electrical induction? Is this electricity was induced by this electricity. Okay, so let's say keep explaining it, because the static electricity in the neutral object is induced by the charged object. Okay, this only exists because of the presence of this inducing it. Okay, all right. Let's say if this disappears, all of a sudden this is gone, and now these negative charge will want to go back to the positive charge, and then this thing is neutral again. Okay, so it will still be neutral. Okay, so that's why this is called induction. Okay, and then another word we say is called induced. Over here, let's highlight this word. Okay, so now, well, then why does the charged object attract this object? Okay, because we say positive charged particle attract a neutral object. Why is that? Well, that's because now this is going to attract, right? And so if you just say this is attract, you only get, like, say, achieve, okay? But you also need to say this one and this one is repel, okay? See how these two are repelling? Positive, but the attraction will be bigger because this is closer to the positive charge, okay? All right, so let's say this. Say So we say the attraction force is bigger than repulsion. Say due to close, we use a word called close proximity. Due to close proximity. So close proximity means like this is closer, so this attraction will be bigger than this repel. Attraction is bigger than the repulsion. Okay, so if we have a thing, originally what did we started with? We started with a charge and just a neutral object over here, and then first due to induction, now it becomes separation of charge, and then the attraction is bigger than the repulsion, so it attracts it. Okay, so this is one situation, and there's the other situation that there is another situation. In this one, say. If I have, I'll take this away, okay? I'll just draw it over here. So you can write this one. Let's say, well, what if the rod is a negative rod? Remember, even I draw a negative rod, there's still a lot of positive in there, okay? Just overall, it's a negative, okay? Say this was a neutral object. Originally, it's neutral. The proton and neutron are completely balanced, okay? And then once we have this negative charge, that will be able to push the electron to the other side. Now there's more electron over here, and then this side will be positive charge. That's because the protons are still here. Okay, so protons still here. So now there is attraction. And this attraction will be bigger than the repulsion. Attraction is bigger than the repulsion, and that's why it's going to attract as well. So it doesn't matter if it's positive, it's negative. If it's coming in close contact with a neutral object, it's going to try to absorb the neutral object. Okay, bring it closer. And once they touch each other, and then this electron is going to jump to here, and now this will be positive, and this will be positive as well, and then they will start to repel each other. Okay, once they touch each other, but before they touch each other, and it's going to be attracted like this. Okay, all right, sweet. So that is the situation about electromagnetic induction. Okay, so for electroscope, I'm going to make a special video about electroscope and see what happens with electroscope. Okay.